Now we'll be looking at non-homogeneous system linear equation. Please look at the previous slide for better understanding. Please like, share and subscribe this particular channel. Let us start now. Now coming to system linear equations. What are the system linear equations? Are nothing but if you have some equations like ax plus by is equal to some value like k value, and cx plus dy is equal to some L value. Okay, such type of equations are called as linear equations. Okay, when you run any of the machine, then you'll be getting A equations. Okay, there are some important points you have to remember. Okay, I'll be saying you one by one. The first one is nothing but a system of equation is said to be consistent. Consistent is nothing but if it has unit solution, a single solution, or infinite solution. You got two equations. If there is solution for it or not. Okay, if it has one solution or single solution or unique solution or infinite solution, then such type of equations are called as consistent. Okay, now come to the next one. A system of equation is said to be inconsistent if it has no solution. We got equations but there is no solution for it, then it calls an inconsistent, or we can say that solution does not exist. Okay, now system equations are of two types. Okay, the first one is nothing but homogeneous system linear equation where ax is equal to 0, and second one is nothing but non-homogeneous system linear equation where ax is equal to b. From this particular equations, okay, we write on a matrix. Okay, then we get both type of matrices. Sometimes we may get an 0 values. Here instead of k, if you have 0, then it becomes an homogeneous. If instead of L it have a 0, then it becomes a homogeneous system linear equation. Okay, what is A is nothing but cofactor matrix, okay, of a variable like A and B, another one cofactors, right? From that one we will be making a matrix, and X is nothing but column matrix, okay, which are unknown variables like X and Y in this particular case. Now coming to B value. B is a column matrix where at least one element will be non-zero. If you make a column matrix from K and L, okay, one of the element will not be 0. And O is nothing but a null matrix. Okay, it is a column matrix where all the elements will be 0. In case of a homogeneous system linear equation, we have an O value, which is nothing but a null matrix. Okay, and when you write A and B together, okay, then it is known as nothing but an argumental matrix. Okay, and it is represented by a C value. Now we'll be looking at non-homogeneous system linear equations. The procedure of solving non-homogeneous equation Ax is equal to B. Okay, first we'll find the rank of a matrix A, and we'll define the rank of a C also, which is nothing but A and B combined we define the rank of it. Okay, the first one is nothing but if rank of A is equal to rank of C, which is equal to nothing but n, then there would be one solution or unique solution, or that particular equation is consistent. Come to the second one. If rank of A is equal to rank of C but less than n, which is equal to R, then we have infinite solutions or consistent. Come to the third one. If rank of A is not equal to rank of C, then no solution or solution does not exist or inconsistent. Okay. Now if you consider an example here, there are three equations are given. Okay, non-homogeneous equations are given. Right? How to write the value of A, X, which is equal to B, and how to write the value of C. Let us look at it. A is nothing but, what do you do is nothing but constant term of a variable will be writing in the form of a row. It becomes 1 minus 1 1. And second equation 2 1 minus 3. Third equation 1 1 minus 1. Coming to X. X matrix is nothing but number of unknown variables X, Y, and Z. Okay, and coming to B is nothing but the values that we get it on a equation 1 0 and 2. Now coming to C, argumented matrix. It is a combination of A matrix and B matrix. we write in this particular format. Okay, if we have a solution, then rank of A and rank of C should be equal to n. Infinite solution, then rank should be of both A and C should be less than n. And rank of A and C is not equal, then we say that no solution. Okay, now we'll be solving one of the problem on it. Now coming to one more question. The question is the system of linear equation 4x plus 2y is equal to 7 and 2x plus y is equal to 6 has. It is asking for type of solution: unique solution, no solution, or infinite solution, or exactly two distinct solution. We have to find it out. First, what we do is nothing but it's a non-homogeneous equation. So we write it in the form of ax is equal to b, and c is equal to nothing but combination of both a and b. Right. So first we'll writing down the value of a, x, b, and c. So a is equal to nothing but values of variables. So it is nothing but 4, 2, 2, and this is 1. Right. And coming to the x value. Here x is equal to x and y. And b is equal to 7, 6. And coming to c value is equal to both combination of a and b. So it becomes 4, 2, 2, 1, and 7 and 6. These are the values we got it. So first we'll find the rank of each of them. For this one, we'll be substituting the values such that we get in a zeros in a row. Okay. So in A operation, first we'll find the rank. Let R1 is equal to R1 by 2. Then what we get is equal to nothing but it becomes 2, 1, 2, 1. Yes or no? Then we'll be subtracting R2 is equal to R2 minus R1. Then A is equal to nothing but we get as 2, 1, 0, 0. So it becomes nothing but in a row matrix. So rank of an A is equal to 1. Right. Now we define the rank of this particular. What operation we have done here, same thing we'll be doing here also. So here it becomes R1 is equal to R1 by 2. Now we get a C value. C is equal to 2, 1, 2, 1, and this is 7 by 2, this is 6. Right. So again what we do is nothing but R2 is equal to R2 minus R1. Right. Then C value would be changing to 2, 1, 7 by 2, 0, 0, and 6 minus 7 by 2. Now this is an a 2 cross 3 matrix. So rank of an a C is equal to 2. So we can see that rank of A is not equal to rank of C. As you know that 1 is not equal to 2. Yes or no? So we can say that it is an inconsistent. Means there are no solutions. Option B. Come next question. For what value of A, if any, with the following system of equation in x, y, and z have infinite many solutions? So they are given the three system equations, right? It is an homogeneous equation. So it becomes Ax is equal to B. Now we have to find the value of A such that it has an infinite many solution. Means rank of A is equal to rank of C, which should be less than n. What is n? N is nothing but an order of A and C. And C is equal to nothing but combination of A and B. Right. So first we'll be writing down the matrices. So A is equal to nothing but it becomes 2, 3, 0. This is 1, 1, 1. This is 1, 2, minus 1. Right. And again B is equal to nothing but we get as 4, 4, and A. Right. and C is equal to nothing but combination of both A and B. So it becomes 2, 3, 0, 1, 1, 1, 1, 2, minus 1, and 4, 4, and A. Right. First we define the rank of an A. Okay. So we'll be doing some elementary operation such that we'll get an A 0 somewhere, and we'll be getting an A value of an A rank of an A matrix A. So here you can see that R3 is equal to nothing but to make this particular value 0, right? In row echo form, it becomes R3 minus R2, right? And similarly, R2 is equal to nothing but 2 times of R2 minus R1. When you do it, then A is equal to nothing but you get the matrix as 2, 3, 0, and this one becomes nothing but 0. This becomes minus 1, this is 2, and this is 0, this is 1, and this is minus 2, right? You can see that row 2 is equal to nothing but row 3, right? Both are same. So when you add it, it becomes 0. So rank of an A is equal to nothing but you get as 2, 3, 0, 0 minus 1, 2, and this 0, 0, 0, right? From this one we can see that rank of an A is equal to 2. So here we got the rank of an A as an a 2. Now in the case of an C, also we should get an as an a 2, right? So by doing some elementary operation, okay, we're doing the same operation here also. Then C is equal to nothing but we get as 2, 3, 0. This is 4. Here it becomes 2 minus, we are doing the same operation, okay, here R2, it becomes 0. This is nothing but minus 1. This is 2, right? It becomes 8 minus 4, so it becomes 4 only. Again here what you are doing is nothing but these two values we are subtracting, so it becomes 0. This becomes 1, this becomes minus 2, and this is nothing but it becomes A minus 4, right? Now what we do is nothing but we are just adding both of them. So C is equal to get as 2, 3, 0, 0 minus 1, 2, it becomes 4, this is 4, and this is 0, 0, 0, and this becomes C, right? Now this is the rank of an A, this is a matrix. So rank of an A is nothing but 2, we got it. Now the whole rank, if you consider A value other than 0, then rank will becomes 3, but it should be 2 only, right? As you know that rank of A should be equal to rank of C. So when A is equal to 0, then rank of C is equal to 2, right? Then only it get satisfied. So value of A is nothing but option B, 0.